Chapter 2, Section 9, Percents. The percent proportion. You can represent A as a p% of B using the proportion A over B equals P over 100. P stands for the percent. Percent actually means out of 100. So for instance, if you had 60%, you could write it as 60 over 100 and they would be equivalent. So it makes sense that in my proportion, I would have the percent over 100. And then when you're setting up the ratio A to B, or A over B, A is going to be a part of the whole, which is represented by B. So you have the part A over the whole thing B equals the percent over 100. The first example says, what percent of 90 is 63? In this case, 63 would be my part, 90 would be my whole, and I do not know the percent. That would be my variable that I am trying to solve for. So when I'm setting up the ratio, the percent ratio, I would have 63 over 90 equals P over 100. We talked about solving proportions in the last lesson. So this time, this is a proportion that we're going to need to cross multiply. So we have 63 times 100, which is 6,300, equals 90 times P. My goal is to solve for the variable P, so I need to divide by 90 on both sides. 6,300 divided by 90 will give you 70% is P. The next example says, what percent of 90 is 76.5? Again, 90 is going to be my whole, 76.5 would be my part, and I am trying to find P, the percent. So to set up my proportion, I would have my part, 76.5, over my whole, which is 90, equals P, which represents the percent, over 100. Notice the over 100 is always going to be there. That's never going to change. When I multiply, remember when I'm multiplying 100 times a decimal, it's going to move my decimal to the right 2 times. So 100 times 76.5 is 7,650 equals 90 times P. Again, I need to divide by 90 to isolate my variable P, and when I do so, I get 85%. Really quickly, just want to point out, my whole is not always going to be 90. That just happens to be the 2 examples that are done in this slide. So if your whole thing was 30, you would have had, or if you say your whole thing was 120, you could have had 76.5 over 120 instead of 90. It's just given to us both times that 90 was my whole. The next example says 77% of what number is 77? 77% is what's going to need to go over 100. And it says 77% of what number is 77. So in this case, 77 is also my part. So I have 77 over x. I do not know the whole number that I'm talking about equals 77 over 100. Well, notice on both of these have 77 on top. So for them to be equivalent, they would also need the same number on bottom. But because this is a proportion, I'm going to go ahead and solve it so that I can prove and use the proportion to solve for x. 77 times 100 is 7,700 equals 77 times x when I cross multiply. I need to divide both sides by 77, and I do end up with x equals 100. The percent equation. There's also going to be an equation that you can represent A as a p% of B using the equation A, which again is my part, equals p% times B, which is my whole. Again, this is going to be an important part of this equation, is that you have to change the percent to a decimal before I can just multiply. So if you had 25%, you would have to move the decimal to the left 2 times. To change a percent to a decimal, you move the decimal to the left 2 places. So 25% would be the same as 0.25. The example says a sweater that normally costs $49.99 is on sale for 25% off. What is the sale price of the sweater? We know that my whole thing is $49.99, and I know that I want to find 25% off of that price. To find 25% of $49.99, I can plug it into my equation, my percent equation. I'm trying to find the part A that equals 25% times $49.99. Now, 25% needs to be changed. I need to move the decimal over twice, which makes it 0.25 times 49.99. When I multiply these decimals, I get $12.50 will be the price that will be 25% of the price. Now, it's 25% off. So now I'm not done. The sweater is not going to cost me $12.50. That's how much is being taken off of the original price. So I need to go back and I need to have $49.99 minus 25%, which was $12.50, which gives me a total price of $37.49 for this sweater. The interest formula is interest equals P times R times T, where P is the principal or the amount that you're going to start with. R is the rate or the percent you will owe or get back, and T is the time. You've probably heard of interest on commercials. A lot of times you hear interest when in regards to loans or credit cards. When you're talking about interest on things that you are borrowing, in this case you're borrowing money from the credit card company or you're borrowing money from a bank or a lender, that's going to be an amount that you're going to have to pay extra. So you're going to owe that amount of money. You can also hear about interest with banks. Sometimes they'll offer you a certain percentage back for keeping your money in their bank for a year or a month, or it's going to be a certain percentage that you'll get back on just keeping your money in the bank. And that's a good deal. So interest could either be a positive thing for you or it could be a negative thing for you. You can either earn interest or you could owe interest. We would love to earn interest, but owing interest is not always fun. The example says you deposit $650 in a savings account that earns a simple interest rate of 5% per year. You want to keep the money in the account for 5 years. How much interest will you earn? Check your answer for reasonableness. Now, $650 would be my principal. That's how much I'm going to put into the bank account. 5% would be my rate, and my time would be 5 years. So when I plug in those pieces, I have interest equals 650 times 5% times 5. Now, 5%, just like when we were using the percent equation, I'm going to have to change the percent to a decimal before I can multiply. 5% as a decimal, when you move the decimal to the left 2 places, I'm going to fill in that empty space with a 0. So 5% is the same as 0.05. Because on the right side of this formula, I am only multiplying, I can multiply in any order that I want to. I'm going to go ahead and I'm going to multiply my whole numbers together first so that I only have to deal with the fraction or with the decimal one time. So I'm going to go ahead and do 650 times 5, which gives me 650 times 5, and then multiply that times decimal 0.5, which gives me $126.50. So just for putting the $650 into the savings account and leaving it there for 5 years, I'm going to earn an additional $162.50 that I could add to that $650 that was already there. That's going to be a pretty good deal as long as you don't need that money for 5 years. You're going to earn $162 for not doing anything extra. Today's assignment is on page 154. It's numbers 2 through 32 even.